Hi guys, welcome to Science Chomp. Today we're going to be looking at specific heat capacity part 3. Now the difference here is before we just looked at specific heat capacity, then we looked at an electrical heater, so that's power times time. And now we're going to look at this new concept where we have Q cold is equal to minus Q hot. Now what does that mean? Well, allow me to explain. What this involves is this device called a calorimeter. We saw actually one of those in the previous section. So what that involves is a container filled with water of known mass. In here we've got a thermometer. So that's a thermometer like that. You've also got a lid like that. And you know the temperature before already. And what you do is you place in here an object of known temperature, which is much hotter. So suppose like the water was, say, 25 degrees C, and this might be at 80 degrees C. Essentially what happens is these two items, the water and this block, end up reaching thermal equilibrium. In other words, they reach the same temperature. And the reason for that is that this gives off heat into the water, so this temperature goes down and this temperature goes up. And we're going to look at a calculation based around this. So this is our question. A 235 gram lead ball at a temperature of 84.2 degrees Celsius is placed in a light calorimeter containing 177 grams of water at 21.5 degrees Celsius. Find the equilibrium temperature of the system, and then they give us a couple of specific heat capacities. So these are our equations. Q equals mc delta T, and Q cold is equal to minus Q hot. Or in other words, the energy that this loses is the energy that this gains. So let's put all of the stuff in here, and let's see if we can work this out. So write it over here. Q cold, this is for the water, equals minus Q hot. And then this is MC delta T for the water and MC delta T for the lead. Okay, so let's see if we can figure out what all of these things are. So first of all, we've got to convert everything into kg. So for the lead, 235 grams becomes 0.235 kilograms. And for the water, it's 177 grams, which is 0.177 kilograms. Now, the specific heat capacity for lead is 128, and for water is 4186. And then for delta T, now remember, it reaches a final temperature, and we've got the initial temperature. So what we've got to do, delta T is always Tf minus Ti. Okay, like that. Let's write that over here. Tf minus Ti. So let's again, what we'll do now is we'll multiply this bit out. So 0.177 times 4186 is equal to 740.922 multiplied by Tf minus, now the initial temperature for water is 21.5, which equals, now one thing I've missed out here is a minus mark, so let's put that in. So we have minus 0.235 times 128, which is minus 30.08, multiplied by Tf minus, what was it, 84.2. Okay, our next thing is to multiply all of this out and all of this out. So let's do that. So we have 740.922 Tf minus 21.5. So I've done minus 21.5 times that, which is, as you can see, minus 15,928.823, which is equal to minus 30.08 TF. So that multiplied by that. Now minus times a minus is a plus. So we're going to do 30.08 multiplied by 84.2, which is 2532.736. Okay. So what we've then got to do is we've got to put the TFs on one side and then these numbers together as well. Right, so let's put this onto this side. So we have 740.922 TF plus 30.08 TF. And I'm going to take this onto the other side. So you end up with 2532.736 plus 15,928.823. So let's work out this bit first. It's 18,461.559. And on the other side, we've got 740.922 plus 30.08, which is 771.002 TF. Now, since this is multiplied by TF, and we want to put it to the other side, it becomes a divide. So we do 18,461.559 divided by that is 23.94, and that's what TF is. TF is 23.94 degrees Celsius. Okay, so both the lead and the water reach this temperature. One last little bit I want to say about specific heat capacity. The higher the specific heat capacity, the longer it takes for something to warm up, and the longer it also takes for something to cool down as well. And that's it. Thank you very much for watching. Hope you enjoyed it. Like, share, subscribe, and if you can, make a donation. That will really help me out. If not, no big deal. Just leave a comment down below, and best of luck in your exams. Goodbye.